All right, hello. These will be Geometry Notes 3.4. Definition, perpendicular bisector. The perpendicular bisector of a segment is a line perpendicular to the segment at the segment's midpoint. In other words, if you have a segment and you bisect it with a line, it means two things. One, it's going to be a right angle. And the second thing, these little segments are going to be congruent. So it cuts it exactly in half at a right angle. With that said, the shortest segment.
Those students who are hosting a German, they will be here at Mount Central at 3:45. This is earlier than we anticipated. So just make sure you make the confirmations at 3:45. They will be here. Thank you.
Sorry. The shortest segment from a point to a line is perpendicular to the line. This fact is used to define the distance from a point to a line as the length of the perpendicular segment from the point to the line. Wow, lots of words there, but let me kind of sum it up this way. If you have a line, I'll put arrows on it, and you had some point up here, the distance from that point to the line is always perpendicular. You see, if you went at an angle out here, I put it in green, if you went from the point to the line this way, that's farther. The green would be longer than the black. Or if you went maybe way out here and hit the line, that would be longer than the black. So again, the distance between a point and a line is always perpendicular. It's always the shortest. With that said, example 1, the distance from a point to a line. Name the shortest segment from A to BC. Well, here's point A, and here's B and C. The shortest distance would be 12, or AP, A to P would be 12. That's your perpendicular. But letter B throws some algebra in here. Write and solve an inequality for x. Well, you see the x minus 8. I want to compare that to the 12. Well, the x minus 8 is longer than the 12. The 12 is always the shortest. So if x minus 8, I would have a greater than symbol. So x minus 8 is greater than 12, and we would solve that by adding 8 to each side. So x would be greater than 20. Now sometimes in the book, they will write it the other way around. They will write the 12 first and the x minus 8. With that said, what symbol goes between those? And that would be a less than symbol, because 12 is your shortest distance. So that gives you 20 is less than x. I prefer the way in the red. I'm just showing you the black marker, just so you when you see it in the book, you'll understand what's going on. Look at the next slide. Sorry, didn't mean to see this. This is not on your paper. I apologize. This next one, this is on your paper. Name the shortest segment from A to BC again. Well, here's A, and here's B and C. Well, the shortest segment would be from A to B, which is that x minus 5. And then part B is write and solve an equality for x. Well, I'm going to do it two ways again. X minus 5, and then I would compare that to the 12. Well, what symbol goes between those? X minus 5 is always smaller, so I need a less than symbol. So then solve that by adding 5, so x is less than 17. If you did it the other way, and sometimes, again, you'll see this in the book, it would be 12 first, then your x minus 5, and just realize that 12 would always be bigger than the x minus 5, so you get 17 is greater than x. Again, I prefer the first way. Next slide. Oops, again, I don't mean to show these. These are not on your paper. 3 theorems. The word theorem is very similar to postulate. It is nothing more than a rule. A rule of geometry. Here's 341. If 2 intersecting lines form a linear pair of congruent angles, then the lines are parallel. I'm sorry, perpendicular. In other words, if this angle equals this angle, that means that's 90 and that's 90, because they have to add up to 180. So what that means is the 2 lines have to be perpendicular. The second one, in a plane, if a transversal is perpendicular to one of 2 parallel lines, then it's perpendicular to the other. In other words, here's my transversal. If it's perpendicular to this line, it has to be perpendicular to this line as well. So I can put a little box in there. Third one, if 2 coplanar lines are perpendicular to the same line, then the 2 lines are parallel. In other words, if this line is perpendicular to that, and this line is perpendicular to that, that means those 2 lines have to be parallel. Again, most of that is intuitively obvious, but there are some theorems, 3 theorems you need to add to your memory banks. Well, look at the last slide here. Now, we're not going to really write a 2-column proof, but I do want to talk about this. It says, given R is parallel to S and 1 is congruent to 2. Let's go mark that. Well, R and S are parallel, so we put these little arrows on there. And angle 1 is congruent to angle 2. Well, if the lines are parallel, wouldn't angle 2 be congruent to angle 3? And if you look up on the board in my room, that's because they are corresponding angles. Well, doesn't angle 1 equal angle 2? Isn't that given up there in my directions? So if you think of that backwards, if 1 equals 2 and 2 equals 3, can you follow the progression that angle 1 would be congruent to angle 3? Angle 1 and angle 3 would have to be congruent. Well, if they're congruent, angle 1 and angle 3 both equal 90 degrees. That's my only possibility. So really, that's 90 and that's 90. In other words, I can put the little boxes in the corner. Well, if they're both 90 degrees, that means that R is perpendicular to T. And that is what I'm asked to prove. I have just showed that R and T are perpendicular. Okay, we'll talk more about that in class, of course. Thanks for watching.